Hello, Zalalam from 2620 is active. Today we will discuss about exception handling.
But before that, if you are new to my channel, please subscribe, and if you like my videos, please like, share
So,
and comment.
before we see how to handle an exception, what is an exception? So, an exception is an error or an abnormal condition that arises in code sequence at runtime or before compile time if the exception or error is a checked type. So when we have an error or an exception during code execution, the error or exception is created and thrown. That means an object representing the error is created or instantiated and thrown by the system so that the coder or the user know what is happening in the code execution process. And these exceptions can be created by the Java virtual machine while the system or the code is running, or it can be created by your application code. And the Java virtual machine usually throws errors and is a type of error which is a subclass of throwable object from the Java library. And when the exception is in the application code, the subclasses are from the exception class. And to handle those exceptions and errors, we use the try-catch finally construct. And as we have said, all the exceptions or errors are subclasses of the built-in throwable class. So Java has got a throwable class which inherits from the object class, but it has got its own specific methods to handle errors, and this class also overrides the toString method of the object class, and this method, the overridden method, is displayed as the error message during the throwing of the exception, or when the error is thrown, this toString method overridden by this throwable class. And if you are creating your own exception, the toString method will show you what error has occurred during runtime. So to review the exception class hierarchy, first class representing errors is throwable, and it's defined in the Java library. And from this, the exception class and error class are created. These are subclasses of the throwable class, and the exception class is used in user code error generation, and it has got runtime exceptions, and these runtime exception classes are defined in the Java language library, and there are two groups, checked and unchecked ones. So the other one is error, and this is, as we have said, thrown by the system or the Java virtual machine. Usually this occurs when there is an error, like for example when the system is out of memory, or the stack is full, or the memory is full, error is thrown. So these are system handled errors. But this exception class is a subclass that is incorporated in the Java language library, and if the error occurs, the runtime exception, whether we specifically handle them in our code or not, they'll be generated when the code runs if there is an error. So when we handle exceptions, we use the class exception or one of its subclasses, as we have discussed. Runtime exception is defined in the Java language, and it has got many subclasses, including arithmetic exception and array index out of bounds exception, and so on. So we use those classes, and we can also create our own exception types or classes by inheriting from the exception class. We will see a little bit later on. how to do that. And as we have said, runtime exception is a subclass of exception, and these are defined in the Java language library, and they handle errors like division by zero, as we have said, or invalid array indexing, which is out of bounds error, and some other errors as well. And class not found exception and so on are also included. And as we have said, they have got checked and unchecked groups. When we say checked, the language checks that the error has occurred before running, so it will alert you. But in unchecked groups, the language during before compile time doesn't know an error is going to happen, but it will occur when the error happens during runtime. For example, in dividing by zero, if you define two variables and the user provides the two variables in the while the program is running, and if the user provides zero for the divider, then the error occurs at runtime. But if you code for a class which is not defined, the compiler will alert you before you compile your code. Okay, that's why checked and unchecked. That's the difference between checked and unchecked errors. So generally we handle the errors using the try-catch finally construct, and generally it's defined as like this. So as you can see, there is a try keyword followed by a curly brace, left curly brace. Then we will code our monitored exception, for example, the division code or array assignment code or any other code which should be monitored for error, and then we will catch the error here, and we have to mention as an argument to the catch block the exception type. If it is division by zero, we will say arithmetic exception. If it is array index problems, then array index out of bounds exception, and so on. So then we will, here in the catch block, we will put our exception handling statements to show what has occurred to the user. And we can have multiple catch statements if we have multiple errors. Okay, so if we have multiple errors, we can use multiple catch statements. As you can see, it's included with an angle bracket because it's optional, and finally block is also optional. But if you want to use your try catch statement with try and finally, you can use try block and then follow it by finally without specifying any catch statement. That's also a valid construct. And the finally clause is if it's included, it will be executed whether there was an exception which has occurred or not. And this is commonly used to handle special issues like if you have opened a file to close the file, or if you have used any resources, then you can free up the resources that has been allocated in the finally clause. So it's very important that we know these concepts when we use our try catch finally construct. So the other issue is the throw and throws keyword, and throw is a keyword used to instantiate a throwable instance. That means while we are coding, we can throw an error if we expect an error occurs in certain conditions. So that should be followed by a catch statement matching that throwable instance. For example, if we say throw arithmetic exceptions, then we have to follow it with a catch statement with arithmetic exception. Okay, otherwise it won't be handled. So if there is no matching default exception, the stack trace will print the error and halt the code. So you have to match the throw keyword with appropriate exception type that has been thrown by the throw keyword in the statements block. And generally it is used as such. As you can see, you have got, as example, you have got void throw demo, and then we use the try catch block, and in the try statement we throw an exception. This exception is a specific type of exception, and then we will follow it with a matching catch with similar exception. Okay, if we say arithmetic exception, we will use arithmetic exception. The other one is the throws keyword. The throws keyword is used to define exceptions that can be thrown by a method. As you remember, we have discussed about defining methods in Java, and you use the throws keyword immediately after the uh, closing parenthesis of a method, whether with argument or without argument, and we specify the exception types that can be thrown by a method. And generally we define it like this. We say throws demo a method, and then it throws exception 1 and exception 2 and so on. So we can have multiple exceptions thrown by a method, and if we have multiple exceptions, they have to separated by a comma. So we can use one exception or multiple exceptions. And when we call this method, it has to be wrapped in a try-catch construct with a matching exception. So if the method throws arithmetic exception, the matching try-catch should have arithmetic exception. If the method has got file not found exception, it should have file not found try-catch construct. And as we have discussed, we can also create our own custom exception class, and this can be done by inheriting or extending the exception class. So generally we do it like this, and we can implement specific methods or override methods from the parent class. As you know, exception class is a subclass of throwable. Throwable has many methods which the exception class inherits automatically, and if we subclass exception, then we will we can also access those methods, and if we want, we can override the methods or implement specifically those methods mentioned or depicted in the throwable class. And generally we do it like this: class my exception, and we use the word extends, and we use a parent class exception, and then we will define our constructors, our methods, and so on. And you can also chain exception handling through specific constructs. We will do and exercise those constructs when we reach to the intermediate level. That's it for this video. Thank you for your time.